Good evening, ladies and gentlemen. This is video number 333. In this model, I am going to estimate ARIMA model in Eviews, and I am also using ARIMA model to forecast future values of some series. In introduction, let me state that time series is a series of data obtained in chronological order. Future values of most time series can be forecasted according to current values and past values of the series. The Eviews software is a software package specifically designed to process time series data. Autoregressive integrated moving average or ARIMA model, a time series forecast method, can be achieved with the Eviews software, and based on the Eviews software, the forecast procedure with ARIMA model is illustrated in this video. As an example, gross domestic product of China is forecasted for some future value based on previous values. So let me first share with you the data of China GDP, and this GDP is a time series ranging from 1952 up to 2015. So this is annual time series data. Let me also share with you the data file in Eviews, and this is the original data that I shifted from Excel to Eviews. So this is the China GDP data from 1952 up to 2015. First of all, I would like to share with you the graph of the China GDP, and this is the graph of the China GDP. And after this, I would like to check its unit root. And first, I would like to check the unit root test with the level of this series. And here is the augmented decay full test statistic. The p-value is 1, so we failed to reject that China GDP has a unit root at level, because this augmented decay full test statistic is greater than the test critical values at 1% level, at 5% level, and at 10% level. And after this, I would like to check the unit root test using the difference of the log of GDP. So this is the first difference of the data with the GDP, and I will show you. This is the spreadsheet of the data. So let me check the unit root test of this. Since this data is already in difference, so I will check this at level and intercept. And this is now the augmented decay fuller test, and this value is now less than these values. So the p-value is also less than 0.05. So we reject this null hypothesis that the log of GDP in first difference has a unit root. So now there is no unit root in this. This data is now stationary. Okay, and after this, I would like to show you the parallelogram of this series at level, and here is the parallelogram of this series. Now if you look at this table, it can be seen that the autocorrelation coefficient of the DLGDP, that is the first difference of log of GDP sequence, is significantly non-zero when the lag order is equal to 1, and it is basically in the confidence band when the log order is greater than 1. So Q can be taken as 1. Okay, and the partial autocorrelation coefficient is statistically non-zero when the lag order is equal to 1, and it is also significantly different from 0 when the leg order is 2. So P equal to 1 or P equal to 2 can be considered, and considering that the judgment is very subjective, to establish a more accurate model, a range of values of P and Q is approximately relaxed and multiple ARIMA of PQ order models are established. So the order with 0, 1, 2 in autoregressive moving average pre-estimation is performed on the processed sample data, and it lists the test results of the ARIMA PQ for different parameters. Now we can compare the AIC, the SC, and the adjusted R-square values for the different orders of the ARIMA model, and finally we get that ARIMA 10 is the preferable model, and we can do that, and I will share with you the results of the ARIMA model. So I'll go to quick and estimate equation, and here I will write GL, GDP and C and AR1. Let me see, what does it show? Sorry. It should be DL, LGDP, and let me see. Okay, so these are the results of the ARIMA model with the autoregressive of order 1, and this is sigma square. So all these coefficients are significant at 1% level, and this is the final model of the LGDP sequence is ARIMA 110, and this equation displays the specific form of the model. So the equation can now be written as that delta LGDP, that is DL GDP, that is log of GDP in the first difference, is equal to 0.110597 as constant plus 0.590915 as the coefficient of the lag value of the GDP, and the standard errors, the t statistics of these two coefficients are equal to 5.30 for the constant and 5.212 for the coefficient of the lagged GDP, and sigma square is equal to 0.004, the R squared is equal to 0.35, adjusted R square is equal to 0.33, and the standard error of regression is 0.065, and the Durbin-Watson state is 1.7067. And after this I will show you the graph of the actual fitted and the residual graph, and this is the graph of the upper two lines. The red one is the actual values of the series, and the green one is the fitted values of the series, and these blue ones is the residual series of the residual. And after that I will share with you the correlogram of this series. So let me go to the diagnostics, and I can show you the correlogram of this series, and here are the correlograms of this series. Now these are the autocorrelation coefficients, these are the partial autocorrelation coefficients, and these are the Q statistics, and here we have probability values of this. So a white noise test is performed on the residual after fitting the ARIMA 110 model. The autocorrelation and partial autocorrelation function graphs of the residual series are shown in this table, and it can be seen that the residual is a white noise, indicating that the model is valid. This model is valid. And after that we can also forecast the values of the series. So let me go to forecast. First, I would like to show you the dynamic forecast for this model, and this is the dynamic model, the dynamic forecast, and I will also show you the static forecast of this model. So let me also show you these are the dynamic forecast of the log of GDP in difference. So this forecast is given by log LGDP F as forecast, and these are the actual, and this green one is the forecasted value, and you see that plus minus 2 standard deviation, this one is the upper bound and this one is the lower bound. I may also share with you the static forecast of this model using DLGDP, and that is given by this. So again, this green is the forecast values of the log of GDP, and these dotted lines are the plus 2 standard deviation, and these are the minus 2 standard deviation than the actual one. So these are the forecast values of this series, and we can also use this model for future forecast value of the this GDP series for China. Ladies and gentlemen, I hope